on answers for multiple ways to approach this same problem as a practice quiz for your section 9.6 stuff tomorrow. So I'm actually going to copy this over twice. Okay. The directions for this one say solve the right triangle. Every time we ask you to solve a right triangle, what we're looking for are all three sides, all three angles. We're going to have to give you 3 pieces of information of those 6 pieces, 3 sides, 3 angles. We're going to give you 3. One of them has to be a right angle. You're going to see that in this angle C here in the red. If it's not a right angle, then this whole unit that we've been doing, this whole chapter 9, you can't use any of it, and then you're stuck with some other stuff that we haven't even bothered with yet. So, you know one angle for sure. The other things can basically be an angle and a side. It can be all 3 angles, and then you could figure out all 3 sides. Or, actually, no, we couldn't do that because it can scale up. Yeah, so you're always going to have at least one side. We might give you another side or an angle. Basically, find the rest. So, right here, if I'm looking at my sides right now, I like to deal with sides, so I'm just going to do a little bit of Pythagorean for this guy. 13 squared, so that's c squared, is a squared plus b squared, right? Our Pythagorean theorem from earlier. Oops, didn't do that right. B squared. So, I'm just going to do the math. We don't know b squared. If I subtract the 121 from both sides, let's see if I can write that. Ooh, that's not so bad. That's going to give me what? 148 is b squared. Let's take a square root of both sides. You got to use a calculator for this. Come on. All right, what do I need? Square root of 148. I'm going to do oh, it's right there. So we'll call it 12.2 if I round that, which makes me have all 3 sides. Great. 13, 11, 12.2. 13 is bigger than both legs, which is what it should be. All right. Now, let's go about trying to find one of these angles here. Group this up and make this guy a little smaller. Do the problem again in a slightly different order to showcase that there's multiple ways to approach these problems, and I don't really care what you use. Since I was given 13 and 11, I'm going to use those side lengths because those are a bit easier to work with than 12.2, which I had to round as well, or square root of 148 if you were exact. And it's my opposite side, and 13 is the hypotenuse. So I want to find an angle, I know the opposite, and I know the hypotenuse. Which trig relationship is that going to be? Sine. So I'm going to write sine of A equals 11 over 13. Oops. Right, that's what that ratio is. From that angle, my opposite side is 11 over 13. So let's figure out what this is going to be. This is basically like what this part right here is what your first question on your quiz is going to look like. To get rid of the sine and move it to the other side, I basically have to take the inverse sine of both sides, so it's going to look like this. Right? The algebra is we're taking the inverse sine of both sides. This is now something I need to type into the calculator. Is this one going to do it for me? I don't know. Let's see. Is that going to do it? Function? Come on. I'm not be able to do it with this calculator. Go get a different one. Hold, please. All right, there we go. Okay, we're in degrees. Make certain that's true. I'm going to do inverse sine, and we had 11 divided by 13. 57.79, so that's going to be 57.8 basically. Let's go back to this. What do we get for A? 57.8. Great. So now I know this amount. I'll even copy this over here. I know this angle. If I have this angle at C is 90, A is 57.8, I have one left. You know what I'm going to do every time? I'm probably going to go back and I'm just going to do that 180 minus 90 minus this guy, right? My angle B, because you could look at it as all three angles add up to 180, but I'm just subtracting the 90 and subtracting the 57.8 to do that algebra already. We did it in the other slide, so I'm just going to do 180 minus 90 minus 57.8 equals B. Let's see what we get. Where was this guy? Okay, let's clear that out. 180 minus 90 minus, what was that? 57.8. 32.2. Cool. You got 32.2 degrees for B. I now know all three sides, 11, 12.2, 13, and I know all three angles. 32.2, 57.8, and then the 90. We're going to give you three pieces. You have to find the other three. Now I'm going to do the same problem again, but I'm going to change the order of the way that I approach some of these and find some of the same basic answers with some different methods, and that's okay. Hey, we've got a problem. We've been told to solve for solve a right triangle, meaning find all three sides, find all three angles. Let's say I start off with this and I see, okay, oh, I don't have any angles. I want to find those angles first. Well, let's say that this time I want to find B. Looking from angle B, I now have 11, which is the adjacent side, and I have 13, whoops, which is my hypotenuse. What's angle or what's a trig function is going to relate adjacent and hypotenuse? It's cosine. So just like in the last to B, so I just need to change my trig function. How am I going to get B by itself? I'm going to take the inverse cosine of both sides, so it's going to look like this. So with this here, take my inverse cosine of 11 divided by 13. And we get 32.2 degrees, which is what we got before. Now, you could go back and you could do trig for this guy. You could do the same setup. I could copy all the math that I did right here to find sine, and I'm going to get 57.8. It's going to be just fine. You found B, you found A. You've got to find them both. Or every time I have two angles, I'm going to do personally, oops, I'm going to do that 180 minus 90 minus the second angle. That's going to equal my A, and we already know that that's going to come out to 57.8. You can type in the calculator, hooray, it's going to come out just the same. Oops. There we go. Okay. So we've got all that, right? There's a different method to sort of approach how to find the angles. Oh my goodness, it's selecting too many things. Let's make those a little smaller. Now, let's go about finding B potentially a different way. I probably would always do Pythagorean if I have two side lengths, but I'm going to show you that you can still do trig with this as well. Right now, I know all three angles. So it really depends on which angle I pick, what sort of trig functions I'm going to use. Let's change this to green here. If I were to go with angle A, I'm wanting this side, which is right next to it, meaning it's my adjacent side. I'm going to think which trig functions have adjacent in them. That's cosine and tangent. So I'm going to show you two different setups. Basically, you could choose either one, or even the previous method that we talked about, Pythagorean. There's like three ways to solve this, and you only have to pick one that makes sense to your brain. I'm going to solve for B by using cosine and tangent. So my first setup is going to look like this. I'm going to say cosine of angle A is equal to the adjacent, which is B, divided by the hypotenuse, 13. Computer's going a little slow. Let's go ahead and shrink this guy. What are we at? 36? Let's make that a 24. Okay? It'd be stacked as a fraction if I were writing it in class, but with the mouse, it's going to be a little tricky. I am also going to do, because it's relative to angle A, that side length I'm looking for is the adjacent side. So I could also do tangent of A is equal to the opposite side, 11, divided by the adjacent, B. Actually, this guy, I'm going to write the math out. I'm going to actually write out both of these. So let's go. What did I say? 11 over B. I think it's just going to make it a little clearer what I'm doing. This is 11 over B. If I come to this guy, this is B over 13. So let's analyze what we have to do in both of these. Again, either method would work. But what are we going to have to do to basically solve for angle A here? Or sorry, we're solving for side B. I already know angle A is 57.8, so I'm going to go ahead and put that in. I should have done that. Right, because there should only be one unknown here. I'm trying to find the side length. So what that's going to look like now, I'll go back to the keyboard here. It's going to be 13 cos of 57.8 degrees equals B. That's it. I'm going to type that into the calculator in a second. We're going to see what happens. But we solve for B. There's nothing else to it. If we come to the tangent version over here, again, you don't have to do both of these. You could do the previous method with Pythagorean on the previous slide, or either one of these. That's the idea. It's being divided by B, and that's a weird spot. So first, I'm going to multiply both sides by B. And you did a bunch of practice with this in that tangent section, 9.4, I want to say. Okay? What that's now going to give me is this. Go ahead and get a text box. Multiplying both sides by B is going to give me B times, I'll put a little multiplication there, tan of 57.8 equals 11. The reason this works is these B's right here are going to cross cancel on the right side. Now, B is being multiplied by something, and I need to undo that multiplication. So I'm going to divide both sides by tangent of 57.8. And again, you've seen this, which is why I said this section is going to kind of bring together everything. Just copy this over. The tangent of 57.8s are going to cross cancel. So what's your final answer going to be is going to be, well, very appropriately, B equals 11. I'm going to divide it by tan of 57.8. So let's go to the calculator and type in both of these. 13 cos of 57.8 is going to be, where's the clear button? There it is. 13 times cos, I just put it right next to each other. It takes care of the multiplication. I'm going to do 57.8. I'm wondering if I made a mistake on the previous one. Thinking I did some bad subtraction. I did. I didn't subtract the 100. We're going to go back and we're going to fix that. But hey, I'm going to make mistakes too, and I caught it here. 13 cos of 57.8 is going to be let's call it 6.9, right? That's how that guy rounds. I can't believe I made that mistake. Oh, it's going to drive me crazy all day. What do we say, 6.9? Yep. So 6.9 is going to equal B in this case. Cool. Let's test it the other version. 11 divided by tangent of 57.8. I'm going to do 11 divided by, and this is just a regular tangent. Do make certain to close the parentheses. It's good practice. Hey, what do we get? 6.9 again. Does it really make a difference which one you use? It comes out the same. Let's go back up here and fix my silly previous mistake. Where I said 169 minus 121 is 148, and that's not true. Let's get rid of this. Sorry about that. That's going to be just regular 48. I can't believe I made that mistake. Yeah, those hundreds are gone. Somebody might be screaming at me on the chat. I'm just missing it. Now, if I take a square root of 48, B is going to equal, hold on, we can do this now. Take 48. Oh, okay, I got to do it differently. square root of 48. Hey, 6.9, okay? So everything does work out. It still is less than the hypotenuse, which it should be. I would have gotten a 3 for that question because I apparently don't know how to subtract 100 minus 100. The idea here is to show you there's multiple ways to approach this. That's maybe that works. I don't care which method you use. Do you want to use a combination of Pythagorean and the smallest amount of trig as possible? Sure. You're going to have to do at least one trig function. It can vary based on the setup. Whichever method works for you is fine. And I just showcased a whole lot of ideas. And now that I fixed this mistake right here, we get the same answer every time, right? A is 57.8, B is 32.2. We see other methods here. We're finding A and B by different methods, but still getting the same answer. B was 6.9. It was 6.9. Is it not going to let me scroll? And 6.9. It doesn't matter if sine, tangent, cosine, as long as you have the right relationships. All right, hopefully that was helpful. You're going to see two problems just like that tomorrow. One of them is going to kind of walk you through the process. The second one is just like this, where it's, hey, what works best for you? With that, I think we're done for the day. Thanks and good luck.